Alright, I have an air fan here put on this little platform. For those of you that are curious, it's actually held on by Velcro, so I can slide it back and forth. And it has a 2-second timer. When I turn on the fan, obviously going to push away from me, and by Newton's third law, the wind will push back on it. Which, notice, makes it go in a clockwise direction. Now notice what happens. I was pointing perpendicular at this point. I'm going to move it closer to the center, to the pivot. And notice it didn't quite go as far. It only went this far before it went farther. What if I give it really, really close to the pivot? Let's see how far it turns. Only went this far. There's less acceleration, so it doesn't go as far in the same amount of time. Well, all of those were perpendicular forces. Obviously, if I turn it around, it should go the other direction, or counterclockwise. Simple enough. But what about if I actually turn it? We already learned that torque is a perpendicular force. Well, let me take this and let's turn it so that it's partly perpendicular. Sorry, it's a little bit busted there, but it'll work. So now I'm going to make it not all the way perpendicular. Some of this force is now parallel to the lever. Notice it went only this far before it stopped, versus, once again, when it's perpendicular. Notice it went a lot farther before it stopped, which means it had a greater acceleration. But what if I can get it to push exactly outwards? Try to eyeball this the best I can. Just a little torque, but that actually could be that it's not level. Or if I turn it completely around, again, no torque. Torque has to be distance times perpendicular force. That's not perpendicular at all. But what about the actual direction of torque? How do we choose to call one positive and one negative? The easiest way to show that is with, here's a ring stand and a moving platform. This is known as the right-hand rule. I take my fingers and I put them perpendicular to my thumb, grab onto a bar, and rotate the bar. Notice, in order for this to be a positive torque, the platform is moving counterclockwise. If I put my hand on the bar and I turn it this way, clockwise, that's a negative torque. Using the same idea here. If it's moving counterclockwise, how would I make that? Well, if I imagine the bar being here, I would have to turn the bar counterclockwise, I know it's going to fall, which would be a positive torque. And if it goes the opposite direction, which is clockwise, okay, clockwise would be a negative torque. Over here on the bar. Oh, he's moving, that works just fine. If I pull on this side, that causes any pull this direction would cause it to go clockwise. Put my hand around the bar, negative torque. If I pull this direction, that would be, a positive torque. And they can counteract each other to where I have a negative and a positive torque equals 0.